Okay, so for today's content, we're going to active transport, and here are our learning targets. I can explain the difference between active and passive transport, and I can explain why active transport requires energy. So if you remember back to when we started talking about passive transport on Monday, we said it was with the concentration gradient, right? Molecules move from high to low concentrations to reach equilibrium. They want to even things out. And that doesn't require any energy output by the cell. So active transport is going to be kind of the opposite. So here is an example of active transport. And if you look at these pictures, you notice that the molecules are still moving through the membrane. Now they're moving from the low concentration, right, out here or inside the cell here to a high concentration. So they're going against the concentration gradient, against the way that molecules would normally want to move. And since they're going against the concentration gradient, it's going to require some energy. So that's why we have this ATP here. And you also notice that it's moving through a protein, right? Not through the phospholipids. So it's going to require a protein because of the energy output. There's going to have to be a protein that facilitates that. So active transport is movement from a low to a high concentration against the way things want to move, against the concentration gradient. And because it's against the concentration gradient, it requires the use of energy or the use of ATP. So in this example, in this picture, you have a very classic example of active transport, which is the sodium-potassium pump that it keeps the resting potential of cells. And in this picture, you see the sodium-potassium pump keeping the resting potential of cells. So it pumps sodium and potassium in opposite directions across the membrane against the concentration gradient so that there's more sodium outside the cell and more potassium inside the cell. And in the next slide, you'll see a video that does a great explanation of a much better explanation than I could show you with just this one picture of the sodium potassium pump. So I'd like you to watch that video. I'd like you to grab the notes. Let me pull them up for you here. So if you're looking at Thursday, if you're looking at the lesson, I'd like you to grab the active transport notes. Those will be, you'll see the exact same picture I just used. So you are describing what's happening here from the Nearpod and then the video in the next slide. And then I would like you to fill out this Venn diagram for active and passive transport from what we did on passive transport Monday and active transport today. And in Friday's lesson, so what I'll do for Friday is I'll put a video right above this plasma membrane passive and active transport quiz, and I will explain that Venn diagram. Okay, so all you need to do today is finish up those active transport notes, right? And then if you have stuff that you're still working on, go ahead and work on that. And I'll go over that Venn diagram in a video tomorrow before the quiz.